Welcome to our today's lesson. And today, in our mathematics lesson, we are going to look at the ratio and rates. Generally, this is not new to you. You have heard of ratios, you have heard of rates. When you look at the ratio, it is simply used in most cases when you are comparing two items or two variables of the same units. In daily lives, we use ratios when we are looking at the ingredients of something, like we can look at maybe ingredients of preparing juice, that is the amount of the water and others. We can look at the ingredients of making tea, where in this case we are looking at tea as contained, it has milk, it has got water, we look at sugar, we look at tea leaves itself. So when we talk about the ratio, what ratio have we used to mix so that we come up with a final product? Besides ingredients, ratio is also used in sporting games, where we can look at the ratio of a team when we are comparing its win and loss. We can also look at the ratio when we are looking at the maps. Generally, the scale maps are written basing on the idea of ratio. We cannot bring the whole or represent the whole land map on a piece of paper, but instead we bring in ratio and say this map was written on this particular ratio, maybe 1 to 50,000. A ratio must have the same units. When we are comparing sizes, maybe the width or the breadth and length, we can also compare it using the ratio. So generally what we are talking about today is not new, it's what we always talk about, but the difference now is that here we are going to look at it and we are going to start calculating these ratios as we compare them. So it is important that we know that for us to write a ratio, it must be written in a way that we are comparing two units, two items that are of the same units. What is the method, or how do we write our ratio? A ratio is simply written in form of A to B. This one can be said as A to B, or sometimes we can say the ratio of the ratio that is of A is to B. So to read this, that is how we represent. The colon is simply is a mathematical symbol that is used to mean ratio. So we are saying the ratio is a relationship between two or more quantities. That is what the ratio is. These quantities must be of the same type and must also have the same units. That's what ratio is. The ratio should be written in the form of A to B, and it is read as I've written, that is A to B. Now, the order at which the ratio is written is very, very important. If you are comparing ratio of two quantities, if they tell you ratio of x to y is 2 to 5, then you cannot say x to y is 5 to 2. Simply what belongs to x is given to x and what belongs to y is given to y. So the order of writing ratio is very, very important. And before the ratio is written, it is very important for you to check and confirm that this ratio has the same units. Like if we are looking at measurements, we cannot write a ratio of kilometers to centimeters, millimeters to deciliters, meters to kilometers. No. Convert and make all the units to be the same. Now, a situation where if we take a ratio, for example, 2 to 3, if we choose to multiply by the same factor, for example, if we choose to multiply 2 by 3, which will give us 6, and choose to multiply again 3 by the same quantity 3 to give us 9, then we say that a ratio, we can come up with what we call equivalent ratio. An equivalent ratio is formed when you multiply the ratio that we have, both the first one and the second one, by the same factor. So generally, we can see that the idea of ratio is a bit friendly because it's what we come across. The questions we are going to look at are questions that we always meet in our daily lives. Only the difference now we are required to calculate. For example, so the question here is, a sample of mixed nuts contains 5 cashews, 12 peanuts, and 2 macadamia nuts. Now, write down the ratio of cashew nuts, that is, write down the ratio of cashew to peanuts to macadamia. 2, the ratio of cashew nuts to the total number. And finally, the ratio of peanuts to others. So in this case here, we need to find out if we have to write the ratio of cashews to peanuts to macadamia. Let's ask ourselves, how many cashews are there? There are 5. How many peanuts here? Peanuts is 12. And finally, macadamia is total of 2. So they are asking for the ratio of cashews to peanuts to macadamia. This is very straight. It will be 5 to, that is for cashews, to peanuts, which is 12, to macadamia, which is 2. So this is the ratio representing 5 representing cashews, 12 representing peanuts, and 2 representing macadamia. It will remain like that. 2, the ratio of cashew nuts to the total number. What is the total number of nuts here? You will add everything here. 5 plus 12 plus 2. 5 plus 12 plus 2. They have said the total. So this is 19. So what is the ratio? Ratio of cashews to the total number. It will be cashews, which is 5, I believe. It is 5 to the total, and the total is what? 19. You see? There we are. Cashews to totals. The last bit is asking for the ratio of peanuts to others. Now, see, look at this, the difference. This was cashews to others. We add to cashews to totals. We added all the contents. But they are asking us this time for peanuts to others. Others, it means those ones which are not peanuts. So, we shall be looking at the ratio of peanuts to others. Others is 5 plus 2, which is 7. So this will be the ratio will be 2 to 7. 2 to 7. Because peanuts is 12 and others it sums up to 7. Now, we want to produce equivalent ratios. Equivalent ratio. Complete each pair of equivalent ratio. So we want to complete the pair of equivalent ratio, and the ratio that we have for the first part is 4 to 9 should be equivalent to 16 to a box that we don't know what we shall fill till we calculate, and B 30 to 15, giving us a box to 5. So for us to attain or get equivalent ratio, we are required to multiply both the first digit and the second digit with the same factor. So for us to get the factor that has been used, let us look at the first digit. It must correspond with the second one. So if this one, the first one, should correspond to this. So what happened to 4 to get 16? And you'll all agree with me that 4 was multiplied by another 4 to give us 16. The same will apply to the second digit. For us to fill that box, we shall be required to take 9 and multiply 9 by what? Multiply 9 by simply 4. So we have multiplied 4 by 4. We shall also multiply 9 by 4. When you multiply 9 by 4, what you get is 36. So that 6 is the digit that is missing, and that 6 is the number we are looking for. So we multiplied both the numbers by 4. For the other one here, again, they are equivalent ratios, but the first one is 30 to 15, and the second one is unknown to 5. So our second number, or second numeral, is going to guide us. So the question here is, what happened to 15 for us to get 5? And you'll agree with me that 15 was divided by 3. So 15 divided by 3, you get 5. That's correct. Therefore, we shall also take 30 and divide by 3 so that we can get our simplest equivalent ratio, and 30 by 3 gives us 10. Let's confirm. 10 multiplied by 3 is 30. 5 multiplied by 3 is 15. So the missing digit is 10. So the equivalent ratio that is equivalent to 30 to 15 is 10 to 5. 10 to 5. Express the following pairs of quantities as a ratio. And the first pair we have is 9 goals to 4 goals. Take note of the units if they are looking alike. $52 liters to 17 liters. And finally, 3 blue marbles to 5 green marbles. So quickly, when you look at this, 9 goals to 4 goals. We said 2 is substituted to me with a semicolon, so we shall have 9 to 4. That is the ratio we are looking for. 52 to 17 is simply 52 to 17. That is the ratio. It's just the manner in which you write your numbers. 3 blue marbles to 5 green marbles. This one will give us a ratio of 3 to 5. Both of them are marbles. So the issue of units being same units does not arise. So sort the following pairs. So the following ratios into pairs of equivalent ratio. So we are interested in finding several pairs of equivalent ratio. And we have 2 to 5, 6 to 12, 7 to 4, and 1 to 2. 4 to 10, and finally we have 70 to 40. We have 70 to 40. Now, we want to find which pair is equivalent. Take note that we can only have equivalent pairs if either it is multiplied by a factor to generate the equivalent factor or divided, both numbers divided. So let us start with this first one. So we shall look at it to find which pair will it get. 2 to 5 and 6 to 12. Is there in any way that you can multiply 2 to 5 and get anything related to this? The answer is no. There's no way. 12 is not a multiple of 5, but 6 is, but that one can't work. 7 to 4. Compare 7 to 4 and 2 to 5. 7 is not a multiple of 2, so it cannot work also there. 1 to 2 and 2 to 5, we find that there's no way. 1 is a factor of 2, but 2 is not a factor of 5. Again, we are striking this one out. We move ahead. This is 4 to 10. 4 to 10. So we take 2 to 5. Multiply by 2 and by 2. You'll find that 2 times 2 is 4 and 5 times 2 is 10. So we have the first pair, which is this one here. So this and that. Now let us look at 2 to 5 and 7 to 40. We put it off right away simply because the first number here is smaller, unlike this ratio. So they are not equivalent. So the first pair that is equivalent, we can bring it here, and this one is 2 to 5 and 4 to 10. Let us look at the second one here, 6 to 12. When you look at 6 to 12, already it disagreed with the first one, so let us look at 6 and to 12 and 7 to 4. 7 is none of the multiples of 6. We brush it out. This one and that. 6 is small, 12 is large, 1 is small, 2 is large. So let us look at the division and see whether it works. 6 divided by 6 will give us 1, and 12 divided by 6 will give us 2. So it is very true here to accept and say that 6 to 12 is the same as 1 to 2. There is a pair there. So I'll come and write here that another pair is so we have two pairs of equivalent ratios. What is remaining, we are not sure whether it is going to form a pair or not. But let's see. We have 7 to 4 and 4 to 10. That one cannot work. 7 is not anywhere a multiple of 4, so it can't work. Let us compare 7 and another one. 7 to 10 to 70 and 4 to 40. This one is making some sense. When you multiply 7 by 10, it is 70. Multiply 4 by 10 is what? 40. So we come and say here that 7 to 4 multiply 7 by 10 gives us 70. Multiply 4 by 10 gives us 40. So we can agree that this ratio is equivalent to that one there. So I can write my pair here and say the one remaining. So from there, I think we've exhausted both. So we are only concluding to say that these pairs are pairs of equivalent they are pairs of equivalent ratios. So we should be able to identify such and find the equivalent ratios. Now, we want to look at this and see if we can agree. Because we are talking of a ratio, then a ratio should also help us to divide numbers. We can ask you, can you divide this in this ratio? I want to give an example. Let us take the quantity or the number 12. can this ratio, can you divide 12 can you divide 12 in the ratio of, I want to give it 1 to 2. Is it possible for us to divide here such that we get 1 to 2? Now, in ratios, there is something very important. Because 12 is our total quantity, then 1 and 2 represents also our total number of quantities. So for us to get what 1 would mean, we shall do the following. You will take the first number, which is 1, over the total ratio, which is 1 plus 2, of the total quantity given, which is 12. So that we will find that this 1 alone represents what amount. Though moving ahead, this one will give us 1 over 3 times 12 by 3, 1 by 3, 4. We find 1 will represent 4. The ratio was 1 to 2. So the second one will be 2 over the total ratio, which is 1 plus 2 is 3, multiplied by 12. By 12, 1, by 12, 4, this one is giving us 8. So we are saying that if we choose to divide 12 in the ratio of 1 to 2, then we shall have it as 4 to 8. And if you are very keen, you'll also learn that this is an equivalent ratio. But the total quantity or the total amount is 4 plus 8, which gives us 12. So we can divide a quantity by its ratio. Given the ratio, we can always divide a quantity. So during a recent dry spell, it rained only 3 days during the month of September. Question: what is the ratio of wet days to total days of the month? What is the ratio of wet days to total days of the month? And 2, write the equivalent ratios of 10 days and 100 days. So before we move on, the first thing I'll want you to tell me is, how many days does the month of September has? How many days? Because for us to work out, we need to find the ratio of wet days, the ratio of wet days to total to total September days. So here, the number of wet days we've been given that month was 3. Total days of the month, which I've asked you to tell me how many days does September has. Some of you don't know. There are several ways of counting it. And if you don't know, you want to look for the calendar, there is an easier way I'll teach you. If you can take 4 fingers like this, and I want to count. So anything that is on the fingertips, it means that month has got 31 days. And what will come between the fingers, it means that month has got either 30 days or less. So let us start. So January 31, February means it's less than 31, so you say that this is 28 or 29. March is 31, April is 30, May is 31, June is 30, July is 31. So January, February, March, April, May, June, July is 31. August, you see, is 31. Because I've moved again to the figure tip. September is 30, so already we have the days here. October is 31, November is 30, and December is 31. Very interesting. The figures can help us to tell us the number of days in every month. So we have seen September falls down here. September has 30 days. So the ratio will be 3 to 30. The second question is asking us to write equivalent ratios. There are many ratios. Equivalent ratios of 10 days to 10 days and 100 days. So 10 days, that is 10 to 100 days. There are so many. One of the equivalent is divide 10 by 10, you get 1. Divide 100 by 100 by 10, you'll get what? You'll get 10. So 10, 1 to 10 is an equivalent ratio of 10 to 100. Another one, we can divide by 5. 10 divided by 5 gives us 2. 100 divided by 5 gives us 20. You see? We were dividing by 5. So 10 divided by 5 is 2. And 100 divided by 5 is 20. So 2 to 20 is another equivalent ratio or to 10 to 100. We can also look at it further. We can choose to multiply by even 2. Ten by 2 is 20. 100 by 2 is 200. That one also is an equivalent ratio. So a ratio is found by either multiplying by the same number or simply dividing by the same number. Now, we've always come across expressions like we have a number with a pronumeral or a noun. So again, that one can be used here, and we should be able to always find what we are required to find. Write down the missing expression. Write down the missing expression. 2 to x is equal to x to dash. 2 to x is equal to 5 to dash. Y to 2x is equal to dash to 8x. And finally, 12xy to 6y is equal to dash to 1. So a question now. Let us look at the first one. So what happened to 2 so that it became 6? You realize when you look at the 2 here, the relationship is that 2 times 3 is 6. The same should apply to x. So this one will be the same as x multiplied by 3. So x times 3 The answer we get is 3x, right? Then our ratio, which is equivalent, will be 6 to 3x. So the missing expression is 3x. Secondly, 2 to x is equal to 5 to dash. Right? This one is an interesting one. What normally happens? This is 2 and the other one is 5. What did we do to arrive at that particular point? So if we want to get this, we are looking for a number because 2 is smaller. So it's like saying 5 divided by x will give us what? Let me use another number. By y, it should give us 2. We want to find the value of this y. I want you to see what we are doing here. So this implies that, take note of this, this implies that we simply multiply this side by y times y times y. When you multiply by y, this side we shall remain with 5 is equals to 2y. We want to find the value of y, divide this side by 2, divide this side by 2, y is equals to 5 over 2. Are we together? So this one, they have not multiplied by a whole number. They have not multiplied by just a fraction, but it is an improper fraction which is a mixed numeral. So for this case, we are going to for us to get 5, we shall multiply 2 by 5 over 2. Right? This is how we arrived at 5 over 2. So that is what we are going to multiply. Take the same and multiply by x so that you get x times 5 over 2 gives us 5x over 2. 5x over 2. Right? So what is our ratio? The new ratio becomes, we are simply saying that 2 to x is equivalent to 5 to 5 over 2x. That is what we are looking for. Let us come to 2. Let us come to 2 pronumerals. Y to x, y to 2x. Y to 2x, y to 2x is equal to dash to 8x. Our interest, the second one, is complete. What happened to 2x to give us 8x? It is x is the same, so we maintain that. So 8 divided by 2 is 4. So they multiplied 2x by 4. Multiplied 2x by 4. Take y, multiply by 4. You will find the missing expression to be a 4y. So what is our new equivalent ratio? It is going to be this way. Y to 2x is equivalent to 4y to 8x. So there we are done with the third part. The last part that we have on expressions we have 12xy to 6y is equals to dash to 1. This is very interesting. Can you see that? Let us take the obvious known. This 12 is to a dash, so we cannot start with it. 6y is to 1. So we are asking ourselves, for us to come from 6y until we get 1, what happened? You find that you divided this. You divided 6y, divide by 6y, it gives us 1. Very good. Therefore, we must divide the other term also by the same. Divide by 6y. In the division here, just to illustrate, it is the same as saying (12xy over 6y). So y and y cancels, it remains 1. By 6, 1, and by 6 here is 2x. So 2x now is our term that we are looking for. So we have 2x there. So the new ratio or equivalent ratio that we are looking for, which is equivalent to 12xy to 6y, is going to be this. Is 2x to 1. Is 2x to 1. So this is when we are searching or finding the missing expressions. Now let us come to the idea of measurements, and we see, and area we see how better do we also go about the ratios. Now let us look at the applications. And now here we are going to use the prior knowledge we know about the shapes, that is rectangles, squares, triangles. Do we know how to find the area? Do we know how to find the area of a triangle? So look at this. Using the dimensions given, find the ratio of the shaded area for the following diagrams. The first diagram we have is a rectangle reading 10 by 5, and inside a rectangle we have a smaller rectangle reading 4 by 2. And then this other side we have a bigger rectangle housing two triangles, and the rectangle measures 20 by 15, and the triangles whose base, so the triangles are similar. The base is what? 10, and the height is 9. So starting with the first one, we first need to know the area, because the question here is, and watch the order. The question is this: find the ratio of the shaded area first to, we need to clarify this. It is the shaded area to unshaded. So let us complete that. So find the ratio of each of the following: the shaded area to unshaded area. So the area of a rectangle is given by length times breadth. That's a complete rectangle. And you'll find that it is inclusive of the shaded. So this one will give us 10 multiplied by 5, which gives us 50 square units. The shaded region the area of the shaded shape, which is still in form of a rectangle, is given by length times breadth, which is 4 times 2, which gives us 8 square centimeters. So the question was, find the ratio of the shaded area to unshaded area. What we have here is the area of a bigger rectangle and shaded area. Is it giving us the guidelines to what we want to look for? Not enough. We need to get the difference so that we can get what is the unshaded. For us to get the unshaded, this is equals to the overall area of the rectangle, which is 50, minus the area of the shaded part, which is what? 8. So the unshaded region is equivalent to 42 square centimeters. So we can now go ahead and answer the question. The ratio of shaded to unshaded. This one is going to be what? This one will be 8 to 42. You see? We have been able to find the area of the shaded to the area of the unshaded. To get the unshaded, we had to subtract. That is what we are looking for. Note that this ratio, the units must be the same. This was 42 square centimeters. This was 8 square centimeters. So we have the same units. For the last part, this one has got 2 shapes. One of the shapes is a rectangle, which we already know. The second one is a triangle. And in most cases, we know that from our previous classes, we know that the area of a triangle is given by a formula a half of base times height. That's what we have. We've been told the 2 triangles are similar. That's what? The base is 10, the height is 9. So we're going to look for the area of one triangle, and then we multiply by 2, and we shall be done. So we are starting with the shaded region, which is the triangles. So it is a half multiplied by the base. What is the base? 10. Multiplied by the height, which is what? 9. And how many? This is for one triangle. How many triangles are here? 2. So we multiply by 2. When you simplify by 2, 1 by 2, 1, you'll get the area of the shaded region, 90 square centimeters. So now let us look at what is housing all these triangles, which is a rectangle. The area of a rectangle with the larger side is length times breadth. The length here is 20. Breadth is 15. So we are multiplying 20 by 15. This one, you'll get 300 square centimeters. 300 square centimeters is the area inclusive of the shaded. We want to find the ratio of shaded to unshaded, so we have to subtract. To find the unshaded region, we shall take 300, which is the area of the whole rectangle, minus 90, which is the area of the 2 triangles. This one gives us the unshaded as 210 square centimeters. So our interest was to find the ratio of the shaded, which is 90, to the ratio of the unshaded, which is 210. So we can have our ratio as ratio is 90 to 210. Do not write units. They are already the same units. We are concerned about the ratio, which we can simplify anytime we find it necessary. Having said this, we can see that we are able to simply apply the knowledge of ratio and find equivalent ratio and come and look at the real life situation where we are going to apply the knowledge. We have applied the knowledge we know about finding the area of the various shapes to give us this ratio. I believe by the end of this lesson, you will be able to handle matters and questions concerning ratios comfortably. For this, we come to the end of the lesson. Thank you.